Okay, so this is going to be the example that we work with today. And I said yesterday, I'm pretty sure it has something to do with jewelry. I totally remembered. Sarah is selling bracelets and earrings to make money for summer vacation. The bracelets cost $2 and the earrings cost $3. She needs to make at least $500 for her trip. Sarah knows that she will sell more than 50 bracelets. Can we create a system of inequalities to determine how many bracelets and earrings Sarah could sell? Now, yes, we know that this is systems of inequalities, but how do you know that when you create something algebraically to represent this, how do you know it's going to be an inequality and not an equation? There's certain words here. Yeah, you pointed out this one here. Make at least $500. Does she have to make exactly 500? No. Could she make 1,000? Sure, that would probably be awesome. She'd be a little excited, I would think. If she wanted 500, ended up making $1,000 for a trip. So that's one. What else in here tells us inequality? Is there anything else that might hint to us? But besides the question, based on the information. She will sell more than 50 bracelets. How many bracelets does she need to sell? 51, 52. Is 50 enough?
No.
No, because it specifically says more than 50. So 50 doesn't count there. Good. What are we already highlighted our important information, right? But if we needed to again, we started with at least $500. We said more than 50 bracelets. What else is key? Yeah, the bracelets cost 2, and the earrings cost 3. Oh, perfect. That information is going to be helpful when we start to put it together for an inequality. What are the variables going to be here? What are we trying to find? The number of bracelets. Good. I heard somebody say the number of bracelets. What else? The number of earrings. Yeah. We're trying to figure out the number of bracelets and the number of earrings that will satisfy both. Can we give these a variable? B and E. Yeah, B and E works. So now let's talk about the income, the money. Can we write an inequality that represents the money she's going to make? Can anyone write an inequality to represent the money that Sarah's going to make?
Okay, 2B.
Or not 2B. Sorry, I couldn't help myself.
Plus 3E is greater than or equal to 500.
What does this mean? All of the money she makes is going to be what?
More than 500.
More than 500 or 500, right? That would represent at least 500. Sometimes when people see the word least, at least 500, they want to put that less than symbol. But when you're putting these together, think about a dollar amount that would work. If she wants to make at least 500, how much money can she make?
501.
501, 502, 1,000, and that total is more than 500, or exactly 500. Okay. How about the 2B? What does this term represent? Is that what the whole term represents? Because the 2 represents that each bracelet costs $2. But what about 2B?
The total cost.
The total cost of bracelets. 2 is the dollars for one, and B is however many she buys. So this term represents the total cost for bracelets, which means 3E represents what? Yeah, the total cost for earrings. So the total cost that she makes off of bracelets, the total amount for earrings, total is going to give her $500 or more. Can we write an inequality to represent that statement? That she knows she's going to sell more than 50 bracelets?
Yes.
Someone else want to come up with an inequality to represent selling more than 50 bracelets?
50 is less than E plus B.
50 less than
B plus E.
Do we agree?
No.
You only said bracelet.
Oh
Say
yeah, I
again?
agree.
She only said bracelets.
She only said bracelets, so she needs to sell more than 50 bracelets. So what don't I need here?
The E.
I don't actually need the E. Now, if she said a total, bracelets and earrings, then that would have been a perfect inequality. But here, she only wants to sell more than 50 bracelets. So this inequality represents that, right? 50 is going to be less than bracelets, or for those of you who like to read it in a linear fashion, the amount that she sells, or the number of bracelets, would be more than 50. Those are the same inequality. Okay, when I read, I have an easier time, just personally, reading it that way. But whichever way, they're the same inequality. So now, if we wanted to graph them, I put X and Y. I'll actually add B and E up here. B and E. You can use any variable you want. I used X and Y to show the axis, because sometimes people get confused, like which one is the X-axis and which one is the Y-axis. It doesn't matter, right? Your graph is still going to represent the same values. One would just look like this, and the other one would look like that. It would just flip-flop. So which one? We'll do this in two colors, right? I'll show it in color on the smartboard. We'll do this top one in red, and we'll do the bottom one in blue. We'll be really patriotic today. Which one do you want to graph first?
The B9, the top one.
That's not, okay, right. How are we going to graph that? 2b plus 3e is greater than or equal to 500. What are our options for graphing?
Are we allowed to change it?
What do you mean change it?
The slope intercept.
You can. What's going to be the issue with slope-intercept form here?
We don't have an equal.
True, but our boundary lines, we treat it as an equation for our boundary lines. So really, the equation that we're going to graph is this, right, when we create our boundary line. In terms of our strategies for graphing, which one might be a little bit more efficient? Either way works for you. You could do either way. If I try to go into slope-intercept form, what's going to happen?
The variable.
What about them? You can do that. You can still put it in slope-intercept form, but if you do, what will you no doubt be working with?
Fraction.
Fraction. Yep, no matter what. You'll have fractions somewhere, which might get a little challenging here because our graph is so large. Right, if we're dealing with 500, we might have to break up our graph by 50s. Only because the graph that's on this board is only so large. Do we have another option? If we don't want to go through the struggle of putting this into slope-intercept form, what could we do? That would be quick, straight to the point, and efficient. To graph that line. What would you substitute?
The B and the E.
Okay, give me an example. You're right.
E is
When you substitute in, think about what calculations you'll have to do and what values might be easier to work with.
B is 250 and E is 0.
If B is 250, E would be 0. No earrings, 250 bracelets. Yep, that works. We can plot that. So if this is our B, 250 and 0 is right here. What else would work? Because you only need one more. You only need one more coordinate that's going to work. And there are others that you can use. If you ended up with a fraction, that's okay. But there are some you could come up with that aren't, that might make your life a little easier as you're going through graphing this, especially for those of you that don't enjoy graphing fractions in a coordinate plane. If B is 100, what would E be? Yeah, 100B and 100E would give us 500, so we can graph that right there. Great, those are actually the two the class earlier today came up with. I would say those two coordinates are probably the easiest to calculate. We had to think about it though, knowing that like you're dealing with a 2 and a 3, like what would work? What coordinates could I work with relatively quickly? Not fast, but. Now the line itself, the boundary line, what will that look like?
Solid,
It's gonna be a solid line. Why will it be a solid line?
because it's equal to a less than.
Yeah, that symbol there says greater than or equal to, which means what do we know about the points on this line?
They are included.
That's a good word. They're included in the solution set. How am I going to figure out which way to shade my inequality? Because I'm still not done. Remember, in inequality, it's all about the boundary line and the shaded solution set.
Substitute.
I can substitute a value. What value do you want to substitute in here? You don't have to substitute in the origin, but notice what happens if we do substitute in a 0 for x and a 0 for y. The entire left side of that inequality becomes what? 0, yeah. 2 times 0, which is 0, plus 3 times 0, which is also 0, equals 0. So 0 would be on the left-hand side if I substituted in the origin. Is 0 greater than 500? No. So if this is not the solution set, what is? The other side. So here is our solution set. So that's our first inequality. What's our second inequality? How do I graph that? Who remembers what that's going to look like? B is greater than 50.
It will be just
Horizontal, where would the line be if it's horizontal?
no, on the y-axis.
Y on the y-axis.
Because it's going through 0.
Is it?
Because how do you start point at 50?
Does it?
No.
Because look at our y-axis represents E, and our x-axis here represents B. What kind of line will that be? What does it mean if B is greater than 50? Or if we're doing a boundary line, we could say B is equal to 50. What would that line look like? Well, the line itself, we're still talking about the boundary line. B equals 50. How would you graph that? You are right that it's a straight line, but the line up there right now is a straight line. So be really clear in your explanation, because I know where you're going. I know what you're trying to say. But all of these lines that we've been graphing are straight. What? Is it horizontal? If it's horizontal, where does it go? Where? Someone, now how many coordinates do we need for a line? 2. Give me one coordinate for B equals 50. What's one coordinate?
1, 1. 2.
Where? Is that a coordinate?
0. 50, 0.
Where B is 50 and B is 0. That's one. Can you give me another coordinate where B equals 0? Any other coordinate on the graph where B is 0? Or I'm sorry, where B is 50. Sorry. A coordinate where B is 50. Any other? This coordinate here is 50, 0. That's right there. That blue coordinate. Can you give me another coordinate where B is 50? Alright. 50, 50 and 2. That one there. 50 and 2. Okay. What's that line going to look like? It's going to be vertical. And will it be solid or dashed? So think about what this means. That boundary line is a vertical line because B equals 50. No matter what your E value is, B is always 50 for that boundary line, which would make it vertical. Now the reason it's vertical, your x-axis was your B value. If your y-axis was your B value, that would be a horizontal line. What's our solution set? Where is B? Where's greater than 50?
On the right side.
Yeah, it's the right. Anything larger than 50 would be here.
Why is it B2? Wait, I mean, like 52.
52? Where's 52? Oh, that coordinate. Eric just gave us another coordinate where B was 50. It didn't matter what E was. The whole idea of that vertical line is no matter what coordinate you are at, B will always have a value of 50. It's the y-axis that's going to change. That's what makes it a vertical line. So this is the shading. You can probably see what would only be blue and what would only be red, but we can look at a drawing to make it a little bit easier. Can you give me an amount of bracelets and earrings that Sarah can buy? Can anyone give me an amount? One value of bracelets and one value of earrings that Sarah could buy. Who has one?
Bracelets and
100 and 100. This value here. Does that work? Yeah, it's on the solid line. Now there's two criteria. Did she sell more than 50 bracelets?
Yeah.
Yeah, and would she make $500 or more?
Yeah.
Yeah, she would make 500 exactly. That's the solution. What else? Any others? Zero earrings. How many bracelets? 250. Does that work?
Wait.
Oh wait, I'm not on zero. Sorry. Does that work? Why is that not a solution? 250 earrings and 0 bracelets.
Oh, I meant 250 bracelets.
Oh, 250 bracelets.
And yeah, that point there.
This one? Okay, 250 bracelets and 0 earrings. Yeah, how much money would she make at that point? That would be 500 exactly. Sorry, I don't mean to answer that. What else? Are there others? What represents the solution set? What color?
Orange.
The orange. Anything in the orange. Can you give me a coordinate in here?
200.
200, 200? Yeah. That's there. That's in the solution set. Right. Anything in here, any coordinate in there is going to be a solution. It's going to be more than 50 bracelets and it's going to be $500 or more. Anything in this yellow area, why are these not solutions? What criteria do they meet and what criteria do they not meet?
They sell 50 bracelets.
Yeah, the money is good. They're selling $500 or more, but the number of bracelets is bad. So this is only a solution. This is only a solution for one of the inequalities. And how about this section here? What's the problem there?
Not selling enough money.
The money, they're not making enough money here. So that part's bad. But they're selling 50 or more bracelets. And the orange represents the solution. Now our graph here is the same thing. So we were actually looking for the solution set where they shared, which would have been, where are we? Anything here. Why am I stopping here?
And you can't sell negative bracelets.
Because you can't sell negative earrings. That would represent negative earrings. Right? The solution set ends at 0, even though we could shade farther. But in a real world system of inequalities, you can't sell a negative number of earrings. So the only addition here is that we're talking now about a real situation. When you see one of these, whether it's on your exam or on the park, they're most likely not just going to ask you to show the graph. Typically, the follow-up to a real-world system of inequalities would be to show the graph, but also to give a value that would work. Because that shows that you can not only graph it, but that you can look at the solution set and identify which area represents a solution of both and which area represents a solution of just one. Okay, so that would be the real-world component. So let's try one. Let's try this. Create a system of inequalities. Create just the two inequalities. We'll graph it together. And we'll graph it relatively quickly. I'm actually going to pause.